Adding corruption layer, or ACL for short, is a very useful tool you can use in you should have in your design toolbox. The pattern is also known as gateway pattern, which is named by Martin Fowler. It's a very useful pattern, especially when you have some integration with the pseudo pattern libraries or APIs, which you don't normally have control of. For example, if you are calling a weather API or map API from Google or other map provider, you don't control the format they provide. But also, you don't want to be impacted significantly when they have some upgrade. When they have change the data structure, change the data field type, you don't want to tightly couple with them. You will need a common place to isolate this change in a single place. So whenever you have to adopt the change, you just have to go to one place to make the change. And that's essentially the ACL, the adding corruption layer, is for. Sometimes it's formed as a big layer, like it has a few modules in it. It might have a group of classes that form the package. It could be a few functions that are doing the conversion. So in this video, we are going to look in a very simple example to say how we can apply the ACL in our React application. So let's get started. We are going to use the context menu example we discussed in a previous video. If you haven't yet, please have a look at this video to have more context. And then let's say how we can apply the ACL and the corruption layer pattern in our context menu example. So essentially, we have a context menu component. If you remember, we have a issue context menu that rely on the operations data structure, and we do the map first and filter it out, and then convert the data into UI. Let's have a look at the context menu on the UI. So it's a pretty simple list. It has assign, which is a button. It should be a button, and this is a link, and this is the comment, and the user can click the menu item to do some interesting action. And the response is like so. It has a few more fields. So it has 4 items, but on the UI it only has 3 because we filled out the log work. And also we treated the assign to me as a link, and for the other 2 they are buttons. So this is the context menu, and currently we have the code like this. After the refactoring, we have a function called convert operation to menu item data, which accepting the operation as a data, and it will check the URL, override it, and for the filter one, it will check if the skip field includes the field or not, and we will skip all the fields that not in the skip field array. And after that, we will do the map. So basically, we'll check if the field is in a dialog field or not. If it is, we will click the button menu. Otherwise, it will be link menu. Yeah, that's pretty much about the previous one. So currently, the problem is that we have this logic scattered in JSX. Even though we could move these functions into a separate file, it's still not that well organized. We could push a little bit further with this current step, meaning we could create an object. In object-oriented programming, class is a unit that can isolate the logic and data and all the domain knowledge into a single unit. So that's what we are doing now. So because we are using TypeScript, we can easily use the class concept to isolate the change into that class. So let's create a folder first called ACL, let's say. And in the ACL, we could create a file called menu item model.ts. This is a typical convention because we are doing the data modeling. In that model, it's a class. and we will, in the class, we will do all the calculation, do the mapping here, and all the logic in that common place. So menu item model, we click that file, and then in that file we define a menu item model class. So this class will accepting a response operation as the input, and inside it will do all the calculation, conversion, and when we use that class, it will be much easier and representing the domain knowledge. So let's define a constructor here, and we are using operation. It's an operation type. So inside the class, we will define a private field called operations. Operation, which is an operation type. So in the class, we simply do a assignment operation, like so. So in this class, we want to expose a few fields. So if we look at the context menu, what we're expecting is a name, a URL, and a field. So we can define 3 getters from that class. And for name, we simply return the name. The URL will be have some logic there, and the field is pretty much renaming the internal legacy field to the field. Let's go back to the class, get name. Let's say the name return a string. So basically we will return this the operation the name. It doesn't change much name at all. And for the URL, it's a string again. But in this time we have some logic here. We will need to convert the URL. So let's copy this logic over. Obviously we cannot use the URL as a variable name here. We can define a given URL is undefined, and we will check the URL override fields. Let's move that, copy that over again as well. This is a map. We copy that over to the class, so that it's a private constant we should be using here. And for the field, obviously we don't have a field getter here. Let's define a getter for the field, which again is another string. We will return this the operation the internal. Sorry, what's that? Internal legacy field. So in here we can simply do this. So we can do this dot field. All right. So in here the URL will be this one, and the given URL or an empty string, right? So now this class is kind of doing the map when needed, but with exposing only the getter to the outside world. Create a test for this menu item model dot test. Yes. I will just copy some helpers over in a test. We don't need the context menu, we don't need a render, we just need a description. Probably you don't need this one as well either. We just do a describe menu item model, and we will need to test that it converts operation to model to menu item model. So let's say we knew a menu. Okay, it's not exposed yet. So it's not exposed yet. Let's go to the class and expose the menu item model. And then we will need to import it here with the operation. Of course, we don't have the operation yet. Let's copy one from the response. Let's copy the first one. This is a response of operation, and then we correct the model. We give it a name or called model, and then we expect that the model dot name to equals to what's the name, assign, right? And if we run the test, it's working. And if we expecting the field, it should be the internal legacy field name. Run test again, and the URL should be this one. And run test again. Yes, the given URL should be this the operation the URL. And if the URL is overridden, it's yeah. And if the URL is overridden, we'll use the override one. Okay, let's try a test again. Okay, this looks fine. We just missed that part. Okay, so now the testing passing. It's all okay. So previously we have a function called convert operation to menu item data. Now we have a class to do the exact same thing, but this way it's a little bit more readable because we have the model. And when you see model dot, whenever you do a model, when you have a model dot, you can see the name field URL, which is much cleaner. And compared to what you have in the response, it's much cleaner. But we shouldn't stop here. If you read the code here, we also have a filter function that basically saying we don't want to add any legacy field. So legacy is a concept we should have in our class. So that means we could have a get here. We can call it is legacy, which return a boolean, and in this function we could just copy the skip the field into our class like so, and then we will check return the skip dot includes list of field, basically indicating whether our model is legacy or not. So for example, if we in a test we could have something like check if a item an operation is legacy or not. So let's see, we have a operation which is this one. So const operation, so we define a const operation equals to this guy, and we knew the model with this operation, give it a name, we call the model. We give it a name, we call the model, and we expect the model is legacy to be true, because the log work is already defined in the field, in the skip fields. So if you run test, it should pass. Similarly, we could have another one, which would be, let's say, the assign again, this one, and it will be false, right? This one to be false. Let's run test again. Yeah, it passes. So that means our model has a field now. It's called is legacy. And then when we doing the pipeline, it's much natural to express that with the object. And in addition, we could move this check into our class as well, our model. So dialog fields include this. That means a button or a link. We could return something like type, right? It's enum, for example. And we could simply define another type here. Sorry, so enum menu item type is, let's say we have a button menu item and a link menu item, and we return this type here, and we will need to copy these dialog fields over to our class file, and we define it just like so. So then we will check if this one includes list of fields. If it includes in a field, we return, what is the type again? It's a button. If the dialog fields include the field, we return button. Otherwise, we return link. So let's say button menu item button type, or menu item button type link type in here. In a test, we could check it returns button type, for example, when it's a button, and that is this one. We could copy this whole thing over, but we will expect that the model dot type to equals to menu. I don't think it's exposed. Let's expose this enum. Export the menu type dot button. Button type. If we run test, it's working, and run all the tests, they're all passing. So now we have this pretty fancy domain object. This domain object or domain model, this domain model is very expressive. If we copy the context menu over to an ACL package and modify it a little bit with this class, let's see how it works. Copy the type as well over here, and now we have the context menu copied over, and in here we do data operation, and previously we have 3 functions, and now we could use firstly we will convert the operation and to create a menu item model from that operation first. So now after this map we have the model object, and then in here we don't have to call a function to do that. Instead we will do a model filtered by the model.isLegacy. Actually we want the opposite, so we don't want any legacy to be existed on the UI. And then last step will be model, and here we don't call the function again, we do model.type, and we check the menu item type. If it's a button type, we will use this guy. Menu key is the model.name, and the name is model.name. And for the link, it will be similar. Link menu name is a model.name. And what else? And then we can get rid of these functions because we have already got the class, and then we don't need operation as well, just the issue here. So now you might think it's not very big difference. It still have the pipeline, it still have the map, filter, and another map. But the point is here, it's more, the code is read more naturally. Like when you do map, you understand that for each operation, it will be mapped to a data model. And then when we filter that for all the legacies, we don't want them at all. And then we do a map, and in the map we say, if the type is a button, we create a button, otherwise we create the link. So if we compare to the old, if we compare to the old, if we compare to the previous implementation, the context menu one, it's if we compare to the previous one, it's pretty much similar logic. We have a map and the filter and a map again, but it's a little bit hard. And if we compare to the previous implementation, it's the steps are pretty much similar, but now the logic is shifted to that model instead of a global function. So now the model is isolate all the potential changes. So for example, if any further operation change happened, we will know that we go to this single place, the model. For example, they change this internal legacy field to something else. We will do the mapping here. And same thing, if we need to make some change in the URL, we go to here and modify the URL modify the URL mapping. And the good thing about this model is that it's more readable. And when you're coding, when you say model, you can see the name, URL type, field is legacy. So these names are all under your control because this class is we created class. So we can define the language we use here, which is pretty aligned with the language we use to build the UI. And potentially this class can be shared in many different places. Also, it's very easy to test. As you can see here, we simply pass in JSON data, and then we can assert the different language we are composing. And this way, our code is much more readable after the refactoring. That's pretty much about anti-corruption layer or gateway pattern. I hope you enjoyed the video. Please let me know what you think, and I will see you in the next video. Bye-bye.